Hi everybody, this is Tristan Moore from the University of Advancing Technology's Learning Enhancement Center. I wanted to give you a kind of broad tutorial on how to create a mini game for Horseshoes in Kismet. And now this tutorial will cover everything from sort of like the beginning to a little bit more of an advanced process, and it should be really good for just getting a strong foundation of how Kismet works. Okay, so let's go ahead and get started. The first thing that we're going to do is we're going to have a scene set up that has these two posts and has sort of like a frame for the posts to be set in. And then we are going to have these two objects here. There's this one that's kind of an arch, and we're going to use that for the horseshoe. And this is going to be a rock that we use to kind of like test that some of our processes are working correctly. Because we're going to have both of these be K actors, and we want to make sure that only the horseshoe and not any other kind of K actor will be able to trigger this event. So when you have a scene set up like this, you can go ahead and go to View, World Properties, and you want to make sure, first of all, that the zone info has the kill Z or the kill zone set low enough that your K actors won't be destroyed. So in the normal, like, default template scenes, the kill Z would be right at the floor, and that would mean that if the objects collide with the floor too fast, they'd actually die. So you have to have it at least low enough that that won't happen. And then the other thing you want to do is you want to have, under our game type, you want to have UT game selected for default game and for game type for Pi, for play and editor. That way we'll be able to use the physics gun. So, okay. Now that we've got that all set up, we can start making the pieces set up the way that we need them to be. So these two pieces right now were just dragged in from the content browser, so they're static meshes. So I'm going to right-click with both of them selected, and I'm going to go convert static mesh to K-actor. And then I'm going to press F4 to open up the properties, and we're going to change a few of these properties to make sure that they work properly. The first one is wake on level start. We're going to turn that on so that they are K-actors from the moment they grow, or the moment they show up. And then we're going to go down to the collision component here, and we are going to change two options. We're going to change collide complex to be on, so we're going to check that box there. And that means that we'll get a better collision that is per polygon rather than using the generated collision or whatever is normally on this. And that way we'll get a little bit more accurate results. And then the other thing is we want to turn off no encroach check. Now, no encroach check is a really like optimization function to make sure that K actors are a little bit less intensive. But since we're using this for an event, we have to have no encroach check off. Otherwise, it can't trigger events. Okay, now let's go ahead and make our triggers. And we're going to use trigger volumes for this. So I already have a builder brush that's the size that I need it to be. And then I'm going to go to the button for volumes, and I'm going to go to trigger volume. And that'll make the first trigger volume. And then I'm going to slide that builder brush over to the other section, make sure it's set in the right spot, and go to volumes, trigger volume. Okay, and then I'll just move the builder brush out of the way so that we can see that those are there. Okay, so we're going to start by building one full section of nodes to make one side work, and then we'll copy it over to the other. But let's go ahead and make the starting events for both of these, just so that we'll have them there. So if I click on this trigger volume, I can go right-click in the Kismet window and go to New Event using trigger 0, touch. And then I'm going to shift over so I can see the other trigger. I'm going to right-click and select New Event using trigger volume 1, touch. And we want to have both of these because we want to change the properties at the same time. So if you want to move a node around in the Kismet window, you just hold down Control and drag it. And then if you hold down Control and click on multiple nodes, you can have both of them selected at the same time, and we can edit their properties together. Okay, so the first thing we're going to do is we're going to change the class proximity type to K-actor, so that a K-actor can properly trigger it. We're going to change the sequence event max trigger count to 0, so that we won't have any limit in the number of times that it can be triggered. And we're going to change it so that it is not player only, and that way our K-actors can affect them. Okay, so now both of those will be working correctly. I'm going to move the trigger volume 1 a little bit further down so we have some room. And I'm going to set up the initial sequence proving that this is doing something. So the simplest thing we can have here is a new action, voice announcement, play announcement. And in this, I'm going to find the section that says UT sequence actor play announcement, and I'm going to make the announcement text say scored. And I'm going to connect that up to touch. So let's just check really quick and see if that's working. And so we have our physics gun. We can drag this over here. And we drop it there, and then we see that every time that happens, then it says scored. But the reason that we have that rock here is to point out what a problem could be with this, which is that if I were to drop the rock, then the rock would score in the same way as the horseshoe, and that's very bad. So we can make a simple node that basically tells it to only acknowledge the horseshoe. And so that would be in a new condition, comparison, compare objects. So I'm going to right-click on the play announcement input, and I'm going to select break all links so that that is no longer connected. And I'm going to connect compare objects to the touch, and I'm going to connect A is equal to B to play announcement. So anytime you leave something blank, if that condition is the one that is met, then just nothing will happen and the sequence will terminate. So this is basically just saying that the only way that that play announcement or anything continuing from that will play is if the object A is equal to object B. And so object B we're going to use as the object that we intend it to be. So that will be the horseshoe. So we'll select the horseshoe in the scene, and then we'll right-click on the B node and select new object variable using kActor 0. Now, in order to figure out which object hit the trigger, we need to actually figure out what the instigator of the trigger was. So when you first look at these kind of nodes, you might think that this instigator node is putting down what the required object would be. So if you were to put kActor 1 in there as the instigator, that would maybe seem like it was correct, but it actually isn't. And the reason it's not is that the instigator here is actually an output, not an input. And you can see that by the shape of the node, which is that it has this kind of triangle shape. So what we want is just a blank object variable that will receive information from whatever object actually hit the trigger. So if this object hits the trigger, then the instigator will be that object, whereas if this object were to hit it, then the instigator would be that object. So I'm going to just hold down the O key on the keyboard and then click, and that will allow me to create an empty object variable, and I'm going to connect that to the instigator, and then we're going to compare that to kActor 1. And if it is kActor 1, then we'll play the announcement. So, okay, every time I move this in here, it will be scored. But if I were to try to do the same thing with the rock, it will not work. Okay, so now that we've got that working, we can start figuring out how far away from the post the object landed. So we can do that really easily with a node under actions. New action, actor, get distance. So we're going to connect the play announcement to get distance, and then we want to compare the distance between the kActor that we used, the horseshoe, and the post. So I already have the kActor selected, so I'm going to right-click on the A node and select new object variable using kActor 1. And then I'm going to click on the post, and then right-click on the B and select new object variable using interpactor 1. So what it's going to do is going to find the distance between these two objects. And then you can see here that this section for distance is an output because it has that triangle shape. So this will give us the distance between them. So I'm going to create a new float variable by right-clicking, and then that will be what we can use to figure out how far away it is. Now, so that we can actually figure out what's really going on here, let's make a log that tells us what the value is. So I'm going to go to New Action, MISC, log. Now, logs by default to only having an object target, but if we right-click, we can select Expose Variable, Float, and then we can connect that to the distance, and then connect getDistance to the log. And then just really quickly in the log, we want to go to the object comment, and I'm just going to write distance from post. Okay, so now let's test that out really quick and see if it's working. Okay, and you can see 1.26 was the distance. And then if I move it in a couple of other times, then you'll see that the distance gets narrower. And every time I drop it in, we get a different distance value. Okay, so that's pretty cool. But right now we're seeing a little bit of a problem, which is this is telling us as soon as it hits the trigger. And we don't really want that because we're throwing it, and we want to know where it lands. So what I'm going to do is, after it says the play announcement for scored, I'm going to put a delay. So if you right-click on the output, you can select Set Active Delay, and we're going to make that 1 second. And that just gives it a little bit of a chance to settle before it actually calculates the distance. Okay, so that's all well and good, but it's not really scoring anything. So what we need is we actually need to create a variable to track the scores, and then we need to have conditions based on distance that tell it what score to give you. So I'm just going to find some blank space, like kind of towards the top, and I'm going to right-click, and I'm going to select New Variable, int, for integer. And an integer is just a whole number like 1, 2, 3, 4, as opposed to a float, which is a decimal number. And so with that variable selected, I'm going to change the variable name to total score. And the int value doesn't matter too much. We should leave it at 0, though. And just to make this a little bit clearer, I'm going to click on this variable, and then I'm going to right-click in the blank space near it and select New Comment. I'm going to call this comment total score. Okay, that just makes it easier to see. Now, the reason that we're putting this here rather than connecting it into anything on the chain is that it's going to be really hard to use multiple times when we're trying to connect it through a large series of networks. So we're going to use what's called a named variable to track this. So I'm going to just make sure that that's kind of over to the side there. That's pretty good. Okay, so now we need to figure out the condition for what our score will be. So I'm going to right-click and select a new condition, comparison, compare float. And that's going to connect to the end of the log. And I'm going to compare this distance to a distance that I have determined to be sort of the threshold for the score change. So I'm going to connect the A to that output of getDistance, and then I'm going to right-click on B and select Create New Float Variable. And for this float value, I'm going to select 50. In fact, actually, I think I'm going to select 60, just to make sure that I've got a decent value that will work best. Now, in the event that the value is less than 60, so that it's closer than 60 units, I want there to be a score of 3 points. And that's actually really easy to do. I can go to New Action, Math, Add Int. Add Int. Now, we're actually going to be adding an integer to this total score variable. So what we need is what's called a named variable. So we're going to go to New Variable, Named Variable, and then under the Find Var Name, variable name, we're going to type in total score. And it should change to having a checkbox behind it, indicating that this is an actual correct name within this sequence. And so then we also want a separate variable that is the value for the score. So I'm going to go to New Variable, int, or you could right-click on one of these connectors and create it that way. And so this value is going to be 3. So in this case, the A is going to be 3, and then 3 is going to be added to our total score. And then the int results will also be our total score. So basically what that means is that if I were to do this multiple times, it would add 3 to this number, and then it would output that result of 3. But then if I were to do it again, it would add 3 to 3, and then output a total score of 6. And then what we want to do is have an announcement describing how many points you got. So we're going to go to New Action, Voice Announcement, Play Announcement. And in the announcement text, it's going to say 3 points. And connect that to the output. And then the last thing we want to do is log our total score. So New Action, misc, log. Right-click, expose variable, int, and then we'll connect that int to the total score. Connect the play announcement to the log. And then I'm just going to select under object comment total score. So that'll make it a little easier to see. Okay, and so this is when the object is closer than 60 units, so it's going to be A is less than or equal to B. But we now need to set it up that in the event that there's a different score, it'll do something else. So we're actually going to do another compare float with a different value. So I'm going to right-click, New Condition, Comparison, Compare Float. And that will be triggered in the event that A is greater than B. So in this value, we're also going to be using A as the same value output by getDistance. But then we're going to right-click and create new float variable, and this one is going to have a value of 100. So we can easily copy this little sequence that we used here to get the other two score values for 2 points and 1 point. So I'm going to select the add int, the play announcement, the total score, and the 3, and I'm going to hit Control W to copy that set of nodes. I'm going to move it down a little bit, and then it's going to be connected into A is less than or equal to B. And then I'm just going to change the values from 3 to 2, and I'm going to change the play announcement to say 2 points. I'm going to grab this one more time, Control W. I'm going to connect that to A is greater than B, so the overall value will be a distance further than 100 units. And then this will have a value of 1. And then the play announcement will say 1 point. Okay. And what's really useful about copying it in this way is that the outputs stay connected to the log, so we can use that same log for all of these and not have any issues. So, okay, let's test that out really quick. Okay, it was 114 distance, and it got 1 point. Now if I were to move it over here and get closer, it's 34, and it's got 3 points. If I move it over a little bit further, I still got 3 points. And 2 points. Okay, so all of them work. Now, let's go ahead and get this set up so that both sides work the same way. And the easy way to do that is really just to copy this entire set of nodes. So I'm going to hit Control W, and that'll make an entire copy of that whole node structure. And there's only a couple of things that we need to change. So we need to connect the touched to the compare object input. We need to make sure the instigator is connected to that blank object variable. And then we need to replace the get distance B actor so that it's the new post. Because otherwise it'll calculate the distance between the other post and your scores will be all out of whack. So okay, now this one is interpactor 0, and this one up here is interpactor 1. So, and because these are using named variables, we don't have to worry about any crazy connections. These are just referencing this node right here. Okay, so let's check that out and see if it works. Okay, cool. And you got 1 point. And also, if you notice that at the bottom where it says 4 total score, we also got 6 total score. And if I come over here and drop it down, we've got 9 total score and so on. So it just keeps going, and we can get as high a score as we can play to. Okay, but now most Horseshoe games require you to stand in a specific position. So we're going to make it that you have to stand on the opposite trigger volume in order to actually activate this event. So that's actually a really simple process. And all we have to do is set both of these triggers to be disabled. So if I click on both of them, if we go down to sequence event, we're going to uncheck the box that says enabled, and then you'll see that it's disabled. Then we're going to move back here for a second, and we're going to make a new trigger event using the opposite volume. So for trigger volume 0, we're going to grab trigger volume 1. So I'm going to click trigger volume 1, right-click, select new event using trigger volume 1 touch. I'm going to select a new action, toggle, and toggle. And then toggles have an event selection, and we're going to connect that over to the event. And then if you touch trigger volume 1, it's going to toggle on trigger volume 0. And if you untouch, it will turn it off. Now it's important to note that although these are going to have, like this event has the same trigger volume as this one, it's actually not disabling the trigger volume itself, it's disabling the event related to it in this specific instance. So we can use this trigger volume to trigger the event involving the other trigger volume, or vice versa, and still have full control. So all we need to do to set up the final process for this to work is just to grab the other trigger volume and do the same set of steps. So we're going to right-click, new event using trigger volume 0 touch, make a new toggle, and then turn on when touched, turn off when untouched, and connect the event to the event that we want to affect. And then just to make sure that this will work properly, we also need to grab these two events, scroll down in their properties, and make sure their max trigger count is set to 0, not 1, so that they can be triggered properly. And just so that we know what's going on, and this is all really clear, let's make an object comment so we can tell that it's working. So under trigger volume 1 touch, I'm going to go to object comment at the very bottom of the properties and type standing on volume 1. And then I'm going to output that object comment to the screen. And then I'm going to go to the other one at the bottom, and my object comment is going to be standing on volume 0. And I'm going to output that object comment to the screen as well. So now let's see if our game works. Switch to the physics gun. And now it says I'm standing on volume 1. And I scored. And I got 1 point because I'm not very good at this. But let's try it on the other side. See if we can get this to work. Oh! Okay, so that one, there we go. All right, so then our system works, and we've created a Horseshoe minigame that we can integrate using only Kismet and no actual code. So that is actually pretty cool, and I hope it gives you a decent understanding of how Kismet works. And in that short period of time, we were able to create a node system that's pretty complex and versatile. And there's a lot of things that you learned here that can apply to other concepts in Kismet. So, okay, thank you for watching, and be sure to check out all of the other tutorials that we have on our channels at the University of Advancing Technology. Thank you very much.